Good morning and Assalamualaikum. My name is Marfa J. Balendong and I belong to the Group 10. And our topic is all about pervasive and ubiquitous computing and embedded systems and wearable computing. So, what are you waiting for? Let's get started. Pervasive computing, also called ubiquitous computing, is the growing trend of embedding computational capability, or generally in the form of microprocessors, into everyday objects to make them effectively communicate and perform useful tasks in a way that minimizes the end users' need to interact with computers as computers. Pervasive computing devices are network-connected and constantly available. Unlike desktop computing, pervasive computing can occur with any device, at any time, in any place, and any data, across any network, and can hand tasks from one computer to another as, for example, a user moves from his car to his office. Pervasive computing devices have evolved to include laptops, notebooks, smartphones, tablets, wearable devices, and sensors, for example, on fleet management and pipeline components, lighting system, and appliances. So, how ubiquitous computing is used? Pervasive computing applications have been designed for consumer use and to help people do their job. An example of pervasive computing is an Apple Watch that alerts the user to the phone call and allows the call to be completed through the watch. Another example is when a registered user for Audible, Amazon's book server, start his or her book using the Audible app on a smartphone on the train and continues listening to the book through Amazon Echo at home. An environment in which devices present everywhere are capable of some form of computing can be considered a ubiquitous computing environment. Industry spending money on research and development R&D for ubiquitous computing include the following: energy, entertainment, healthcare, logistics, and military importance. The history. Ubiquitous computing was first pioneered at the Olivet Research Laboratory in Cambridge, England, where the active page a clip-on computer. The size of an employee ID card was created, enabling the company to track the location of people in a building, as well as the objects to which they were attached. Caption: this diagram of pervasive computing shows the role of sensors and other low-power embedded devices in pervasive computing. Pervasive computing and the Internet of Things. The Internet of Things, or IoT, has largely evolved out of pervasive computing, though some argue there is little or no difference. IoT is like more in line with pervasive computing rather than Razor's original view of ubiquitous computing. Advantages of pervasive computing. As described above, pervasive computing requires less human interaction than a ubiquitous computing environment where there may be more connected devices, but that extraction and processing of data more intervention. Because pervasive computing systems are capable of collecting, processing, and communicating data, they can adapt to the data's context and activity. That means, in essence, that a network that can understand its surroundings and experience and quality of life. The examples of pervasive computing. Examples of pervasive computing include electronic toll system on highways, tracking applications such as Life 360, which can track the location of the user, the speed at which they are driving, and how much battery life their smartphone has, Apple Watch, Amazon Echo, smart traffic lights, and Fitbit. Embedded systems and wearable computing. What is embedded system? An embedded system is a combination of computer hardware and software designed for a specific function. Embedded system may also function within a larger system. The systems can be programmable or have a fixed functionality. Industrial machines, consumer electronics, agricultural and processing industry devices, automobiles, medical equipment, cameras, digital watches, household appliances, airplanes, vending machines, and toys, as well as mobile devices, are possible location for an embedded system. While embedded systems are computing systems, they can range from having no user interface or UI, for example, on devices designed to perform a single task, to complex graphical user interface such as in mobile devices. User interfaces can include buttons, light-emitting diodes, and touchscreen sensing. Some systems use remote user interface as well. Markets and markets, a business-to-business research firm predicted that the embedded market will be worth of $116.2 billion by 2025. Chip manufacturers for embedded systems include many well-known technology companies such as Apple, IBM, Intel, and Texas Instruments. The expected growth is partially due to the continued investment in artificial intelligence or AI, mobile computing, and the need for chips designed for high-level processing. History of embedded system. Embedded system date back to the 1960s. Charles Stark Draper developed an integrated circuit in 1961 to reduce the size and weight of the Apollo guidance computer. The digital system installed on the Apollo command module and lunar module. The first computer to use IC, it helped astronauts collect real-time flight data. In 1965, Altonetics, now a part of Boeing, developed the D-17B. The computer used in the Minuteman, a missile guidance system. It is widely recognized as the first mass-produced embedded system. When the Minuteman II went into production in 1966, the D-17B was replaced with the NS-17 missile guidance system, known for its high-volume use of integrated circuits. In 1968, the first embedded system for a vehicle was released. The Volkswagen 1600 used a microprocessor to control its electronic file injection system. By the late 1960s and early in 1970s, the price of integrated circuits dropped and usage surged. The first microcontroller was developed by Texas Instruments in 1971. The TMS-1000 series, which became commercially available in 1974, contained a 4-bit processor, read-only memory or ROM, and random access memory or RAM, and it cost around $2 apiece on bulk orders. Also, in 1971 released what is widely recognized as the first commercially available processor, the 404-bit microprocessor was designed for use in calculators and small electronics. Through it required internal memory and support chips. The 8-bit Intel 808 released in 1972 had 16 KB of memory. The Intel 880 followed in 1974 with 64 KB of memory. The 880 successor, the 86 series, was released in 1978 and still largely in use today. Examples of embedded systems are automobiles, mobile phones, industrial machines, and medical equipment. Characteristic of embedded system typically consists of hardware, software, and firmware. Can be embedded in a larger system to perform a specific function, as they are built for specialized tasks within the system, not various tasks. Can be either microprocessor-based or microcontroller-based. Both are integrated circuits that the system computer power. Are often used for sensing and real-time computing in Internet of Things devices, which are devices that are Internet connected and do not require a user to operate. Can vary in complexity and in function, which affects the type of software, firmware, and hardware they use, and are often required to perform their function under a time constraint to keep the larger system functioning properly. Structure of embedded system. Embedded systems vary in complexity but generally consist of three main elements. The number one is hardware. The hardware of embedded system is based around microprocessors and microcontrollers. Microprocessors are very similar to microcontrollers and typically refer to a CPU or central processing unit that is integrated with other basic computing components such as memory chips and digital signal processors or DSPs. Microcontrollers have those components built into one chip. The number two is software and firmware. Software for embedded system can vary in complexity. However, industrial-grade microcontrollers and embedded systems usually run very simple software that requires little memory. Number three is real-time operating system. These are not always included in embedded system, especially smaller scale systems. RTOCs define how the system works by supervising the software and setting rules during program execution. Types of embedded system. These are a few basic embedded system types which differ in their functional requirement. They are mobile embedded systems are small-sized systems that are designed to be portable. Digital cameras are an example of this. Network embedded systems are connected to a network to provide output to the other system. Examples include home security systems and point-of-sale or POS systems. Standalone embedded systems are not reliant on a host system. Like any embedded system, they perform a specialized task. However, they do not necessarily belong to a host system. Unlike other embedded systems, a calculator or MP3 player is an example of this. Real-time embedded system. Give the required output in a defined time interval. They are often used in medical, industrial, and military sectors because they are responsible for time-critical tasks. Traffic control is an example of this. What is wearable computing? A wearable computer is any small technological device capable of storing and processing data that can be worn on the body. wearable computers are designed for accessibility and convenience, as well as improvements to workplaces by making information quickly and readily available to the wearer. Common examples of how wearables are worn include on wrist as watches or jewelry around, neck similarly to a lanyard or necklace, on the user's head, in the user's shoe, or carried in bag. Wearable devices continue to evolve and become more efficient, manageable, and adaptive to the everyday needs of users. As the technology behind human-computer interaction improves, devices are created and adapted to integrate seamlessly into users' lives. Something as common as a smartphone is considered wearable technology because it can be clamped onto clothing or held in a bag. Some technology has been built into a watch or pair of eyeglasses to add information in the user's perception of the observed world through augmented reality, speech recognition, or virtual reality or VR capabilities. Devices that monitor health can keep track or attributes such as sleep patterns, exercises, and heart rate. Some popular examples of wearable devices include the Apple Watch or Google Glass